I will be talking about OpenLineage in Airflow.
Did I say Maciej is brilliant?
So it's great that most of you won't be at Airflow Summit because I would spoil the presentation there. Can I?
You want to share your screen?
Yeah, I want to share my screen, and I hope it will work. I don't want. No, that's not what I want to share. What I want to share.
Make sure you unmute.
So okay. Let me. I need to make sure that I'm sharing everything, not just the. Oh yeah, that's good. Share. Is it working? So okay. So let me start to showing you how to use it. And first, so since Airflow 2.7, the integration starts of Airflow itself as Airflow provider, and you can use it by basically using official Docker Airflow image, which is where it creates all. So to use it, if you just install it, it doesn't do anything because you need to configure it. And to configure it, you basically need only to tell it where to collect the events. So this Airflow config, right? You have to put your transport configuration JSON in string type, and this configuration actually just means you send HTTP events to this market instance. There are more configuration, like you can tell it in which namespace to send the events, which will be used in the job namespace. You can disable it. You can put your additional extractors, which are kind of legacy feature for this provider. But if you used OpenLineage Airflow before, you might want to use it. You can disable it from source code for Python and Bash operators if you want, and you can put config path if you have configured it in some different way. So let me run a quick demo, and I hope this will be the first possible demo because it's so easy. So I have nothing in Marcus, and I hope next time I can use metaphor here, for example. And I have some random DAX, right? Let's run a DAC, and I hope it will work because I have a nasty habit of using actually development version of Airflow and from main, so something might go wrong. I'm running some Snowflake, very basic Snowflake DAG, and it ran 2 times because I had DAG stopped and run it. I don't have anything here, right? And now I have some data, right? I have a graph, and that's basically the demo. So I have a very screenshot version of it here. So how does it work, right? Basically, our idea is that each operator in Airflow exposes lineage themselves and maintains the contract itself. The lineage contract is exposed by the data structure that we provide in the provider. And so by using this way, where the code is not some external thing to the operator code itself, we are ensured that it will keep up with evolution of the operator, because we test there that guarantee that the implementation is secure. It makes sense, right? And then if you change it in a way that will break it, you will break it. You'll see the tests. If you push it to the Airflow repo, it will break there, and nobody will measure PR until you fix it, hopefully. So it looks like that. For example, this is BigQuery to GCS operator, and it's simplified version of it. But basically, what you need to do is implement one of those methods. There's there's a get OpenLineage method to start, complete, and a failure, and they cover different states of which your task can end up. It starts, right? We send an event that the job started, it completes or it fails, and we send an event about that. We basically take, in this case, some UI where we copy the data from BigQuery. We take the BigQuery data set as an input. We'll put the Google storage output, right? And so how does this structure look like? Basically, a list of inputs and outputs and run facets and job facets. It's not an OpenLineage event, as you would see in.
Sorry, it's my bedtime.
Yeah, it's not a full event that you would see in your like OpenLineage backend, or if you wanted to create your own implementation. Why? Because we want to attach some facets ourselves in like the Airflow provider, because we have some data information that is useful for every event. It wouldn't make sense for every operator to basically do the same thing ever and ever again. So we'll use this feature and it will work. Right. So outside of this, we have some common parts to the provider. It's basically we are called by the Airflow feature called listener API, which basically notifies this start, complete, and fail states. We check if the operator has some lineage implementation, right? If it doesn't, we do some default thing. We call the methods, and we enrich the data with the common level facets. So yeah, we also have some additional part there. We provide some additional utilities that you can use if you want to implement your own implementation of OpenLineage operator, like the SQL parser that Pavel told us about. We provide DAG monitoring, so we send an additional events for like start of DAG and complete of DAG that are like used as a parent of all those operator events. And we provide backup mechanism. If you use like other Airflow's lineage mechanism, we use those this lineage if we can get it automatically. So there's a backup mechanism basically. So yeah, if you're creator of operator, what would you do? You have to define the methods in the same class as the rest of the code. Why? Because, as I said before, it makes sense to test together, and you can encapsulate data that otherwise be public inside your operator. So, yeah, before I say what does it mean, I want to say that not everything needs to have lineage. Airflow has hundreds of operators, and most of them are dealing with data, right? But some of them, like Slack API operator, is used to push notifications to Slack, compound Slack, or you can create a bucket, create some VM, or do something like simple HTTP operator, which just calls some endpoint, and we have no idea what actually it does, right? It's very generic. So I don't see a point to implementing this. You can if you want, but yeah, it doesn't make that much sense as some other else. So how does it work, right? So we get called and start before the operator's execute method actually runs, right? And then either on complete and on failure facets methods are run. Why does it matter? Because some data is set up on operator only on execute method. So for example, in this case, we have some job ID that we got from running query, basically. You know that it runs in SQL, right? We get the job ID, but we don't get the job ID before we actually executed the job, right? So we can't get the lineage on start. We only can get it on complete. This matters because we sometimes can get the additional metadata in complete, right? Also, that some data like processing, amount of bytes processed, or amounts of rows returned. stuff like that can only be done on computers for obvious reasons. So it makes sense to have different methods sometimes, sometimes it's not. So what we don't want to do for operator creators is like get actually the metadata prepared for on execute. So we want to store the data like .id and do the actual work on in OpenLineage methods. Why? Because it can be heavy, right? Or if not heavy, then it can like have some network calls. If somebody doesn't have lineage configured, your work done in the execute method will still be executed. So you will do some work that will never be used. And by doing this in the Apache methods, if user doesn't have them configured, it will never run. So we avoid some work that wouldn't be necessary. So, and the last part, what we'll do in the future. So first, we need to cover more operators, more providers. There are still tons of operators that aren't covered, right? And we want to do this. We ask community to help us with that. If you maintain some provider operator, consider if you want to contribute this support. We will help. We also want to add support to more, right? There's still a lot of ground to cover. Second, we think about integration with IP48 datasets because this is a cool feature that isn't used, that basically hasn't lived up to its full potential yet, right? If you have already set up data set IP48 datasets, then we don't take advantage of that, right? You have data aware scheduling, but the data lineage mechanism doesn't know about it. It would be cool to have this covered. In the other way too, right? If you like use data aware scheduling, but you don't know that the data set is being updated somewhere else, you're not also using the IP48 to its full potential. And I think there's a lot of common ground here. Second is like Python operator, right? Python operator is most used operator in Airflow, I think. I'm pretty sure that's true. If anyone has other data, then feel free to correct me, but it's not covered. Why? Because you can execute arbitrary Python code there. And the task flow is also like Python operator underneath, like actually something like underscore Python wrap operator, but it's the same. So what we think to do is to add support for hooks, and the hooks can track their own lineage, right? If you use like, I don't know, BigQuery hook or Snowflake hook, they can do basically the same thing that we did. So save some usage information, and then Python operator would look at those used hooks and basically take their lineage as their own. So we would have support for the case where users are actually using hooks. If you're still using like arbitrary Python code, right? You want to probably add some helpers. We also need to like more think about this more, but it would be nice if like you could emit your own lineage more easily if we don't cover that already. So the same goes for, I thought I have another slide here. The same probably goes for like Kubernetes pod operator and Kubernetes related pods. And basically if you schedule something somewhere, then we probably can do a better job than we can do now. And all this can happen because OpenLineage is in Airflow, and otherwise it wouldn't make sense because we can do this from the outside. Thanks.